This question is from the 2024 higher level DCG paper, and it's question C2 on structural forms. The image on the right shows a golf practice net. The shape of the net is based on a hyperbolic paraboloid. The projections of a similar practice net are shown in figure C2 below. The surface of the net is formed by extending the hyperbolic paraboloid surface ABCD. Part A, draw the given elevation including the elements as shown. Part B, project an end view of the hyperbolic paraboloid surface ABCD. Part C, complete the end view by extending the elements of the hyperbolic paraboloid. Show clearly how to locate point P. And part D, show the curvature of the surface when intersected by a horizontal cutting plane passing through points D and B. Okay, so we start off with our front elevation. Scale is 1:10, so we can just cross out a 0 from each measurement. We've technically no plan view, but your cutting plane is there, so it's going to be on the bottom, so leave a bit of space below for that. Okay, full height 130. Okay, XY line across the page. Then we'll start off by finding A, B, C, and D first. So we'll start off with a center axis. Going up the middle. A is up a distance of 130. C is down a distance of 30. Technically below the ground, but we need to find these to find the full shape. Oh, C, sorry. Axis then up 30 and draw the line across. And distance out on each side is 110, so 55. D and B. Okay, that's the full shape. I'll get the outline shape now as well. We're told it's radius 75, so if we go down 75. Draw the line across. Circle a bit on the top, and then the two side pieces just go straight down. Okay, that's front elevation there fully set up. We need to draw the elements now within this. So they show us how many? 1, 2, 3, 4, 5 spaces. So we're going to do equal division of the line, 5 equal spaces. So line at any angle from one side. Mark 5 equal spaces on it. Shine the last point back to the end of the line using your slide and set squares, and then bring them all back at the same angle. And that divides it up into 5 equal spaces. Now, I'm going to do the same. I don't have to do the same on the top because these two lines both match up on the line AC. I can just bring those points straight up, and that will divide up the top line into 5 equal spaces. Now, I'm not going to draw the lines. I'm just going to put a little dot on the line. that divides that top line into 5 equal spaces, and I can bring them straight across then to divide up that side line. So you only really need to do that once, rather than wasting time doing it 4 times. Bring those top ones straight across for here. Now, join up opposite ones, so those top ones are going to join down to the bottom right. And these ones to the bottom left. Okay, front elevation there fully set up. Part A complete. Part B, project the end view of the hyperbolic paraboloid surface A, B, C, D. Okay, so I'm going to bring my lines across. Construction lines. And then measurements were told A. So I'll pick a point for A. Let's say it's over here. Distance between the views doesn't matter. We've no plan view here either. Distance for C is across 200 from that. That there is point C, and then D and B are across 450. That's D and B. Okay, we can draw in the lines. Now, same thing again, we're going to find the elements on this. So I can bring over the lines from front elevation. Same for the bottom ones. Okay. And now join them up the same way. So let me see. That one went to there, so that one's going to go to the very bottom one down here. Okay, and that gives us that curved surface now. Now we have to draw in the curve, and it only goes down as far as the ground. It just kind of goes as a tangent each one. Okay, so that's that curved of the net there at the back. As part B finished, part C, complete the end view by extending the elements of the hyperbolic paraboloid and show clearly how to locate point P. Okay, so we need to go back over the front elevation now and extend them until they meet the surfaces here, or the edge of the object. So that one meets at that point. Okay, so that gives me a series of points. Now we really need to do one side because the other side is symmetrical. That should find it over here for me. I need to extend these ones now the same way. And then I need to go back over to here and bring these straight across. So the top one there goes from that point. That gives me a point on that first line on the curve. Second one. Fourth. And then we can extend B as well. B goes to there. I can extend that one. That brings me to that point. Now I might need another one down here, so I can extend the hyperbolic paraboid to get another point down here by bringing them the same distance. So I'll show you what I mean by that. If I extend the line AB and extend the line DC, I can use the same distance as I had there between those 2 points and mark that down here. So that gives me that point. And then I go down to this, get the same distance I had there and mark it down here, and that gives me another element now on the hyperbolic paraboid. So I can join those two and extend to the flat surface there. Do the same thing over here then, so I need to do extend that line down and extend this one. So that distance from C I'm going to mark down to here, and that distance between those two there I'm going to mark down here. Draw in that straight line element and see where those two cross over. So it hit at that point, I can bring that over to here, that gives me another point there. Now, I can draw in most of that, so I'll draw in what I have there already. Okay, it goes down to that point. Now, we need to find point P down here at the bottom. So, I can just use another element, or I can use the main one there. I can use AB, find it below the surface. So if I extend AB, it hits at that point. If I extend the edge down, I can do the same here. Extend AB. Well, extend AB down like that. Hits at that point, so bring that across. So that there would be the next point now. So if I bring this round, that is not going to be seen. That there, it should be the exact location of point P. Need to find one below the surface to get the exact point. Okay, that's part C finished. Part D then, show the curvature of the surface when intersected by a horizontal cutting plane passing through points D and B. D and B are here, so if we slice it through there, what are we going to see? So the best place to draw it is probably down at the bottom here, so I'll draw a line across, bring down point D, and point B. Now we're going to need points on that line, so we have a lot of points there. We probably don't need to bring down them all. Once they're kind of evenly spaced, bring down that one. Now we'll go with symmetrical, so that one. Now, heights for this, I'm going to go back over now. End elevation will show the depth. B and D is that point there. So the next one over then will be that one to there. So mark that distance on your compass. Back down to plan. Scribe there and there. That's the first one found. Next one, I didn't use that one. I went to the next one there. I went to there. Set the compass to that. Straight down. And then there's two either side. Now these ones are very close to each other. They look almost all on the same point. So I'll just go with the two side ones. Okay, that gives me that curved shape. I need to draw it in then just by joining up the dots. Okay, that's the curvature found in that view, which is what they asked for in part D. That's your full question finished.